In section 2.2, we are going to look at adding and subtracting angle measures. So the first term that we need to know when we're talking about angles is the term adjacent angles. And that means there are two angles that have the same vertex and share a common side. They also do not have any interior points in common. So if we look at this example on the left, we have two angles. We have angle BCD right here, and that can also be referred to as angle 1. And then we also have angle DCE, which is referred to as angle 2. And you can see that they have an overlapping side. They both share this ray CD. So if we right here we have angle 1, angle 2 are adjacent. The vertex, the common vertex is C, and their common side is ray CD. Starts at C, goes past D. So this is an example of two adjacent angles. Over here, we have a couple more examples. These are examples of not adjacent angles. So angle 1 and angle 2 here, they have a common vertex, but they do not share a common side. So this means they are not adjacent. And over here on the bottom, this example, if we were talking about angle ABC and angle DBF, they again have the same common vertex but no common side. These two angles also have interior points in common. If we look at this space in the middle, this shaded region is inside of my angle ABC and it's inside my angle DBF. So since it shares some common interior area, they are not adjacent. Okay, so using our adjacent angles, we can look at an angle addition postulate. So if we look down below, this says that if point W lies in the interior of angle XYZ, then the measure of angle XYZ, so that's what this little M here means. It means the measure of. So measure of XYZ, which is this piece, XYW, plus the measure of WYZ, so we have this angle plus this angle is equal to the measure of XYZ, which is the whole thing. So this is saying our two parts added together is equal to the whole angle. Example 1 says that the measure of angle 1 is 20 degrees. So the first thing I'm going to do is label that on my figure. Angle 1 is 20 degrees. Then I know that measure of angle 2 is 85 degrees. 85 degrees. And I'm looking for the measure of angle ADB. And this right here is supposed to be a D, not an O. Okay, so ADB. Well, to find that, we know the two pieces of our large angle. If we know those two pieces, the two parts, we can take our part plus our part equals our whole, since these are two adjacent angles. So I know that measure of ADB is going to equal 20 plus 85, which is 105. Okay, example number 2. Our given information here says that the measure of MNQ is 127 degrees. So MNQ is this angle right here. That is 127 degrees. Here, this angle MNP, that is a straight line. And a straight line always has 180 degrees. So if I'm looking for QNP, this piece right here, I know my whole thing equals 180, and that 180 is going to equal the measure of QNP plus 127. So if I want to figure out what QNP is, I can take 180 minus 127, and I am left with QNP, which is 53. Last example here we have is number 3. Our angle ABD is equal to 99 degrees. So if I label that ABD, that whole thing is 99 degrees. Then inside here I have this piece right here is x plus 9, and this piece over here is just x. So if I'm looking for angle CBD and ABC, those are my two parts inside there, I'm going to need to set up an equation using my x's. So if I'm taking this angle ABC, which is x plus 9, and add it up with this angle CBD, that would be x, and I know that whole thing is equal to 99 degrees. Now I can solve this equation for x and figure out what those angles are. So if I have x plus x here, I'm going to combine like terms. 2x plus 9 equals 99. Subtract 9 on both sides, I get 2x equals 90. Divide by 2, and I get x equals 45. So that tells me that my angle here, CBD, that is equal to x, and I know that is 45. And then my other angle, ABC, is x plus 9. When I plug in 45 for x, I get 45 plus 9 is equal to 54.